Hey everyone, welcome to more calculus. And today we're going to start our look at integral calculus with a few things which are not actually integral calculus, or at least not calculus in the way that you might be thinking they're calculus. In any case, this is a lot of geometry that we're going to do, so get yourself your area formulas and let's head over to the other screen. Okay, today's theme, or this chapter's theme, is going to be dinosaurs and Jurassic Park. So Jurassic Park, also referred to as Jurassic World, is an American science fiction media, and etc., etc. Let's just go down to where we're going to do some work. So we have observations of a flock of the theropod Gallimimus conducting to ascertain the running speed of this flocking chicken mimic. One observation found a Gallimimus maintaining a 27-mile-an-hour running speed for 22 seconds, and this problem says to graph the velocity curve of the Gallimimus. Looking at the graph over here, I see that we have velocity in feet per second. So the number we're going to want to graph is 39.6, and then we're going to maintain that for 22 seconds. That gives us a curve that kind of looks like this. I'm putting the sides of this rectangle here because, well, we're going to need them later. Because when considering the coordinate axis, of course, your graph should be the shape of a rectangle. And then what are the sides of this rectangle? Well, the width over here is going to be 22 seconds. And then the height of this rectangle is going to be at 39.6 feet per second. All right. Most people don't realize that when you create dimensions, you've created a multiplication problem. I think you all see the multiplication symbol there. And when we look at seconds and feet per second, there is some kind of a correspondence with those units. Second over here and feet per second there. So that's probably going to play something into what we're going to be doing here. Maybe you've already heard this in physics or whatnot. Next step here is, what is the area of the rectangle, including units? I don't know about you, but when I multiply those numbers up here, 22 times 39.6, I'm going to get myself an 871.2 feet. And like I was saying before, feet per second cancels out with seconds, giving me units of feet. And now we can answer the next question. How far did the Gallimimus travel in those 22 seconds it was observed? And this was the same way of a different way of asking the same question, which was the area of the rectangle. The distance here is the same as the area of the rectangle, which is 871.2 feet. All of that in mind, we have this confirmation of a theory, and the theory is the net distance traveled is the same thing as the area below the velocity curve. Now that thought there is going to be very powerful to us. It's going to be something that carries us throughout all of our integral calculus. It's even more powerful when we think about it in terms of rate. In fact, the net quantity accumulated by a rate is the same thing as the area under the rate curve. It just so happens that in the velocity curve, the rate is in feet per second. But if you did this in any other rate, like cubic inches per minute, or if you did, liters per second, you would just accumulate those cubic inches or those liters, and you would get the quantity out of that. So that being in our brain, let's go to this problem with the Roseland Apartments. The Roseland Apartments are filling their new water tower using an old water pump. The rate at which the water is pumped into the tank is given by the linear graph below. How much water is pumped into the tank during the first 24 hours? Well, let's take a look at this graph. This is gallons per hour, and this unit down here is hours. If I close off the end of the figure, I create what looks like it's a trapezoid. It's a trapezoid. Let's shade in that trapezoid. So if this is the rate function in gallons per hour, and we find an area by closing off the curve with respect to hour, the area of this should be the total number of, and I'm looking for the unit here, gallons, total number of gallons pumped in those 24 hours. All we need to do is find the area. The area of any trapezoid is 1/2 of base 1 plus base 2 multiplied by height. In our case, things are going to be kind of different because the left side is going to be the base, so it's actually height 1 plus height 2 multiplied by the base. Again, the trapezoid is sideways to the way we normally see it, so the bases are actually the heights. All right, anyways, let's substitute some numbers in here. 1/2 of 200 plus 176 multiplied by 24. That gives us 4,512, which tells me that 4,512 gallons of water are pumped into the water tank during the 24 hours. And this is all we needed to learn for today. We are already at our important ideas. So what are the important ideas? The first thing I want you to think about is, what is a rate function? And a rate function is a function where the output is some unit per time, like miles per hour or gallons per second. When graphed versus the correct unit of time, the area under a rate curve will give the accumulation of whatever is in the rate, so miles or gallons, etc. The area under the curve then, very importantly, is the amount of accumulation that takes place during the time period. And even though this isn't a geometry class, you're going to have to use geometry to find the area for the most basic of the functions. There won't be any crazy area formulas here in calculus, so you do need to know, rectangles, trapezoids, circles, semicircles, etc. Let's check our understanding. A Parasaurolophus dinosaur named P38NT accelerates at a constant rate from 15 to 24 miles per hour for 1 minute and 12 seconds, which is the same thing as 0.02 hours. So how far did P38NT run during that time? The hint here is that the velocity curve is linear. So let's graph our velocity. We're starting at 15 miles per hour, and we're going to 24 miles an hour when the hour is 0.02. We'll connect those 2 points with a straight line segment, and then we'll consider the area under that curve. Now that is a trapezoid, and it is a sideways trapezoid, so when we find our area, we're going to look at height 1 and height 2. Substitute values in here. The height on the left side is 15, right over here. The height on the right side over here is 24. And then the base here, that's going to be 0.02 hours. We probably should have also checked to make sure that the units matched here. That's miles per hour, and this is hours. So yeah, they do match here. Doing all the multiplication, we get A equals 0.39. So P38NT runs a total of 0.39 miles during those 0.02 hours, which is 1 minute and 12 seconds. And that's a nice, gentle introduction into this next part of calculus. And I'll see you guys next time. Have a good one.